So how do we know what numbers would be good to try with synthetic division in order to find our zeros? That's where the rational zeros theorem comes in. If we've got a polynomial function, we can write it in the following form. A sub n is the leading coefficient and a sub 0 is the constant term. We call p the factors of the constant term and q the factors of the leading coefficient. And what we do is we take the division p divided by q of all plus or minus combinations of these factors. So if we have the polynomial 2x cubed plus 11x squared minus 7x minus 6, we want to find some good ideas, some good options for numbers to try. The factors of the constant term are 1, 2, 3, and 6. So 1 times 6, 2 times 3, both multiply up to 6. And then the factors of the leading coefficient are just 1 and 2. So then we want to take all combinations of p divided by q. So we're just going to list them out one at a time. 1 over 1, 2 over 1, 3 over 1, 6 over 1. Okay, so 1, 2, 3, 6, and then 1 over 2, 2 over 2, 3 over 2, and 6 over 2. Notice these all have a plus or minus. Could be positive or negative, which is why we can use Descartes' rule of signs to decide if we want to check the positives or the negatives first. Also notice that perhaps there are some repeated things that we could try. Here's 1 over 1, and that's the same as 2 over 2. Here's 3 over 1, and that's the same as 6 over 2. So I've got 1, 2, 3, 4, 5, 6. 6 different options here, but since it's plus or minus, that doubles it. That gives us 12 different numbers that we could try, which is much better than an infinite number of possibilities to try. Let's take a look at Descartes' rule of signs to see whether or not we should try the positives or the negatives first. So we start off with a positive, and it looks like there's just one sign change. That is one positive real zero. If we write out f of negative x, then all of the odd-powered coefficients are going to change. So we have negative 2x cubed plus 11x squared plus 7x minus 6. So now, looking at our sign changes, we go from negative to positive. This stays positive, and then to negative. So there are 1, 2, or 0 negative zeros. Okay, well, what should we try? How about we just start at the beginning and try x equals 1. So if x equals 1, notice we don't have any missing terms. We've got our coefficients 2, 11, negative 7, and 6 from above. So 2 carries down. 2 times 1 is 2. 11 plus 2 is 13. 1 times 13 is 13. 13 minus 7 is 6. 6 times 1 is 6, with a remainder of 0. This is good news because that means x equals 1 is a 0, or x minus 1 is a factor. So our equation becomes f of x equals x minus 1 times this stuff that's left over, which is 2x squared plus 13x plus 6. Now we can attempt to factor that second part. So x minus 1 times, I'm thinking we need a 2x and an x, and then if we try a 6 here and a 1 here, 2 times 6 will give me 12, and that'll give me one more to give me 13. If these are both positive, everything works out. So we have just factored our polynomial. Now that it's factored, we can set each piece to 0 to find the zeros. So this factor gives me this 0. This factor gives me my next 0. This factor gives me the next 0. Oh, and what we notice is that there is one positive 0 and two negative real zeros.